Hello, and welcome everyone. Today, we're diving into a groundbreaking concept called memory beyond recall. We're going to explore how a dual-process cognitive architecture is stepping up to completely replace traditional RAG systems, paving the way for us to build truly self-evolving LLM agents. This presentation is based on some highly innovative research by the Large Language Model Department at Tencent. Let's begin by addressing a common pitfall in AI today, which we call the retrieval trap. Right now, standard systems treat personalization like a flat text retrieval problem, essentially treating AI memory like a dusty filing cabinet. They collapse the nuances of belief revision and causal links, tuning everything exclusively for surface-level keyword recall. But true personalization demands what we call the cognitive requirement. An intelligent agent needs to model exactly how a user's beliefs are revised over time, deeply understand why their preferences shift, and extract latent psychological patterns across completely unrelated domains of their life. This brings us to a massive paradigm shift. We are moving away from the current RAG, update-in-place approach toward dual-process cognitive memory, or DCPM. Our core philosophy shifts from treating memory as passive storage, a flat database, to treating it as active cognition governed by a capability hierarchy. Instead of updating facts in place and losing intermediate states, DCPM uses diachronic chains to preserve the full trajectory of a shifting belief. For cross-domain inference, we move from simple semantic matching to discovering latent core schemas. And importantly, at read time, we shift from slow, LLM-heavy evaluation to lightning-fast, LLM-free traversal. You can visualize this architecture as a cognitive capability hierarchy. At the base is the passive foundation, a vector store that guarantees zero loss of raw inputs and atomic facts. Existing memory systems almost exclusively sit right here in this bottom tier. Moving up, we find structured memory, which tracks diachronic belief trajectories and maintains a stable user identity. At the very top is proactive cog evolution, where the AI uncovers latent intentions and cross-domain schemas. To achieve true personalization, your system must ascend this entire pyramid. So, how does DCPM make this climb? It relies on two distinct systems. System 1 is what we call the daytime writer. It handles synchronous, on-demand, incredibly fast encoding of facts directly from user queries. Then, we have System 2, the nighttime sweeper. This runs asynchronously offline, pulling from the vector database to induce deep, cross-domain patterns and core schemas. Let's zoom in on System 1. It is designed to be fast, synchronous, and non-destructive. The process follows 4 rapid steps. First, raw persist ensures zero-loss logging immutably before any LLM is even invoked. Second, an extraction phase uses a single LLM call to pull out long-lived identity attributes and facts. Third, reconciliation compares these new items against existing facts to decide whether to simply add, update, or supersede them. Finally, a batch upsert instantly pushes the processed data into the store. Because it's invoked selectively, System 1 keeps chat latency strictly bound to just a few seconds. A truly magical feature here is the supersedes mechanism, which stops the erasure of context. In a traditional update-in-place reality, when belief A changes to belief B, the AI permanently loses the causal middle, it completely forgets how the user arrived at their current state. The DCPM supersedes mechanism fixes this by recording bidirectional pointers over a flat vector store. A single query hit triggers an instant traversal that recovers the full evolutionary arc of a thought. To see this in action, imagine tracking a user's psychological journey. Let's say in month 1, the user believes group fitness is highly motivating. By month 4, they take a break and try Zumba. By month 7, they realize solitary hiking is more fulfilling. The RAG reality retains only month 7, so if you ask about the past Zumba experience, the agent hallucinates. The DCPM reality preserves the entire chain. It intrinsically understands the user's evolution from external group motivation to internal solitary fulfillment. Now let's talk about System 2, the offline abstraction engine. It operates in a continuous, three-step loop. First, a pre-process stage clusters fresh facts using automated algorithms, totally bypassing the LLM. Next, an induction agent examines these clusters to create structured schemas and latent intentions. Finally, the cross-domain sweeper scans the entire graph to find unexpected behavioral collisions, forging high-level core schemas. Running completely offline during idle windows, System 2 requires zero synchronous user wait time, yet it compounds the AI's intelligence exponentially overnight. This engine allows the AI to graduate from mere observation to active anticipation. By summarizing within domain behavioral regularities, it generates schema nodes. By recognizing underlying anxieties, like spotting a latent concern about an upcoming career transition, it generates intention nodes to proactively check in. And critically, both of these higher-level nodes automatically bind to the underlying raw facts, ensuring the AI can always perfectly cite its sources. The real heavy lifting happens in the cross-domain sweeper. It evaluates data across two spaces simultaneously. It maps a source schema into a behavioral space via an LLM description, and into a semantic space via direct text embedding. It then runs a collision scan. If it detects high behavioral similarity, say, above 0.72, combined with low semantic similarity, it flags a collision detected. We can plot this beautifully on a dual-space collision matrix. Semantic similarity is on the y-axis, behavioral similarity is on the x-axis. Surface matches and unrelated data are simply ignored. But the bottom right quadrant, high behavioral, low semantic, is where the magic happens. True personality traits hide exactly here in this cross-domain collision zone, where user actions look entirely different on the surface but actually share the exact same psychological root. Here is a concrete example of synthesizing that root. Suppose the AI spots schema A, wellness and exercise, and schema B, gardening and teaching. On the surface, their semantic similarity is just 0.18. But behaviorally, they score a massive 0.81. A collision is detected. The AI then induces a core schema, an organic cultivation mental model. It realizes the user deeply believes that meaningful outcomes require patient, consistent micro-investment over time. Without the dual space test, these two domains would never be connected. Now, the agent can apply this profound psychological framing to completely new areas of the user's life. So, how does this rich context affect speed when you actually ask a question? We use a read path with zero LLM overhead. When a query comes in, it hits the vector store using hybrid similarity. The system instantly traverses those attached supersedes pointer chains and traces upwards to surface high-level schemas. The total complexity is logarithmic, meaning read latency is dominated solely by fast vector search. The LLM is bypassed entirely during the read phase, perfectly matching the speed of basic retrieval systems but delivering massively richer context. The impact on implicit personalization is phenomenal. When benchmarked on Persona MEM v2 accuracy, standard tools like ZEP and MEM0 score around 38 to 41%. DCPM Lite, relying only on System 1, jumps to 54.1%. But DCPM Full reaches an incredible 59.3%, surpassing even full history long context Oracle benchmarks that frequently suffer from lost-in-the-middle effects. System 2 alone delivers an unprecedented 5.20-point leap. Deconstructing this cognitive leap proves that every single layer of the capability hierarchy is empirically necessary. Losing the diachronic history guts fundamental reasoning, causing an 8.10-point drop. Disabling System 2 entirely drops performance by 5.20 points. And turning off the dual space collision engine drops it by 4.10 points, clearly proving that the cross-domain engine drives the vast majority of the AI's upper-level intelligence. What's perhaps most striking is what we call the 1.3% leverage. Raw facts and identity nodes make up nearly 80% of the database volume, but they drive minimal differentiation. Conversely, cross-domain core schemas make up a mere 1.3% of the data volume. Yet, this tiny 1.3% alone carries a massive 4.1-point leap in AI intelligence. As the research highlights, true agent intelligence isn't about remembering more facts. It is about abstracting better insights. In conclusion, the journey from basic storage to true cognition requires 3 fundamental steps. First, stop overriding. We must honor human evolution with diachronic supersedes chains. Second, embrace asynchrony, offload deep abstraction to a slow, nightly System 2 engine. And third, find latent links, use dual space collisions to map the core schemas of human behavior. Long-term memory is no longer a retrieval problem. It is a reasoning process. Thank you.